Good morning, my name is Ivan Tuấn. Thank you for joining us on this presentation. Today I would like to talk about our recent research, formalizing solution to REST API practice, a design anti-patent. The presentation will consist of 7 sections. Session 1 talk about the context of this research. Session 2 summarize the related work. Session 3 describe the approach. Session 4 discuss the REST API practices and their concrete solutions. Session 5 explain how we evaluate the work. Session 6 introduce some threats and our approach to minimize them. And finally, Session 7 conclude the work. Let's start with Session 1. In this session, I will talk about the context of this research. In the last decade, the information presented on the internet evolved from a very simple static web page to extremely complex interactive web application. As you can see on the screen, the first one is a web application that can work a fully functional IDE for every programming language. The second resource is a weather forecast service that shows the current wind direction with hundreds of moving animations. In addition, users expect the same experience on their phone and desktop. All of these made possible by the representational state transfer architectural style, which separate the concern of server and client. The server store, process, and send data from the client, and the client present the data and handle user input. Like other architectural styles, REST API can be more or less well defined and used, so they are subject to good and bad practices. For the term practice, as Oxford Dictionary define, is the way of doing something. In REST API, a good practice is a good way to implement the REST API that solve the problem, simple, much understandable, and can be reused. On the other hand, a bad practice while solving the problem but not good in other aspects. For the word anti-pattern, a defined by the famous book by Pro, is a commonly occurring solution to a problem that generate a negative consequences. An anti-pattern has a problem, the best solution, and an alternative good solution. In general, we propose 3 contributions: review academic and grant literature to identify REST API practices, propose practical solutions to the practice, and validate our solution with surveys and interview. In the next few sessions, we will show how we could make the contribution, but at first, we will show you the related work to our research. Now we know what is the good and the bad practices, as well as the anti-pattern and the context of the study. Let's talk about the related work. For related work, we look into both academic and grant literature. In 2008, Tikoff defined and explained 7 REST API best practices. 2 years later, Rorici, Grasso, Junio, and Campo proposed the practice content negotiation. In 2011, Mace published a book called REST API Design Rulebook, consists of 84 rules to design a consistent REST API. Many rules have the same principle and can be combined into a single practice. And in 2012, Frederick defined 3 best practices. Another one proposed by Pama and others in 2017. Finally, today, we introduce 2 new practices, which is server timeout and post-put pass returned. For some practices, there are existing solutions, especially for the response caching and the list pagination. These 2 practices were fully supported by the web framework that we examined. For the content negotiation, Laluma and Layada suggest using a proxy between the client and the server. The proxy can convert the response to a required format. Another approach is using if-else conditional construct to perform the content negotiation. They use an XML file to configure the algorithm, but they also admit that this approach is too simple and need a way to complex handle negotiation. For forgetting hypermedia best practices, Liskin, Singer, and Shader suggest using a grapper module to convert the normal response to a response that includes the hypermedia information. This approach could be used in an old REST API system, but not for a new one. For API versioning, Kaminsky, Litu, and Muller design a chain of adapters. This adapter will adapt their own system to the new version of the API, creating a change. However, the more of the version, the longer the change and the slower the system. Another approach, Leiner, Mishmay, Rosenberg, and Dusda use a proxy between the server and the client. Developer implement the selection strategy to redirect the request to the correct server. For server timeout, Isbury and others propose a design known as HTTP polling. We will extend this design in section 4. And finally, for the response caging and list pagination, the web framework with SMI fully support them. In the next slide, we will talk about the approach to solve the problem. So in the introduction, we know the context of the research, then we read and understand the related work, which is actually part of the approach. To begin, we search for definition of the REST API practice. Then, on each REST API practice, we search again for the solution. We did the search in both academia and gray literature. On each paper or article, we read carefully to understand the proposal, the technical solution to the REST API practice. Later, we compare this solution with ours. After extensively review the academic paper and gray literature, we identify 18 practices. We divide these practices into technical and non-technical categories. The technical practice can be confirmed by an architectural solution or using the web framework feature. The non-technical practice, on the other hand, require developers to constantly pay attention to follow. Usually, the non-technical practices are domain-specific or business-specific. To look for the solution, we, for each of the technical practices, except the response caching and the list pagination, we SMI 23 design patterns by the gang of 4 to design a correct solution. If there is no solution or no design pattern could solve the problem, we extend our search to technical blog posts, tutorial, or even the Stack Overflow answers. Using this methodology, we are able to define and design the solution for the REST API practices, which we will show you in the next session. Moving up, in this session, I will talk about the REST API practices and our solution. There are 4 subsections for each practice. Due to the time limit of this presentation, I will present the 4 subsections of the first practice. For the other practice, I will only present the problem and the solution. The other details are available in the paper. We had a sample implementation of the solution hosted on our GitHub repository. The sample had the implementation for both Java Spring and ASP.NET Core. It also had an API testing definition for Postman if anyone needs to test the solution. The first practice is the content negotiation. Basically, the client can only process one format of the response. Based on the client request, the server should serve the resource in that format. We expect that the resource of the same type should be served in various formats. The server set a default format if the client does not specify, and the implementation of each data format should be easy modifiable. The solution to this problem is quite simple. We could use the factory design pattern. The object factory class will construct the response in the required format. We also examined the 2 most popular web frameworks, which is Java Spring and the ASP.NET Core, to see how they solve this problem. Both of the frameworks support content negotiation. However, in case of Java Spring, there are some limitations. The format serializer cannot be customizable, and you will need to annotate the model class for it to work correctly. Sometimes this annotation requires you to change the model structure, but fortunately, that both frameworks allow you to ignore the built-in support and implement your implement your own content negotiation feature. The next practice is endpoint redirection. The client requests a resource that will move to a new location. In this case, the server should return an HTTP 300 OQ move to the new location in the body. Then the client can automatically redirect the request to the new location. To solve this problem, we could use the inheritance and polymorphism property of the object-oriented programming. Each version of the API will implement an interface. On the new version, the API class will extend the redirector class that implements this interface. Whenever the client goes to the own resources, the redirector could redirect them to the own client that handle to the own class that handle the resources. The next practice is called entity linking. In short, when a server responds, the related resource should include it in the response, so that the client will know what it can request next. To implement this practice, we use the visitor pattern in cooperation with the language relation. The visitor could visit other class to collect the related resource data. The relation is used to collect the class with method information to construct the URI. Because the web framework uses classes and method annotation to automatically construct the UI of the API. The next practice is called API versioning. Basically, a REST API server should support multiple versions. The client that's not up to date could request the old version, making it more time for its developer to working on the new version. Again, we could use the process design pattern. The new version will implement the interface of the old version. There is an instance of the old version inside the new version that works as a process calling to the actual logic of the old version. If the new versions need to support multiple old versions, it could implement multiple interfaces of the old version. Next practice is the server timeout. The client sends a request that starts a long running operation on the server. While waiting for the server to respond, the line goes offline. The server never knows, wasting its compute time for no longer needed resources. There is no OOP design pattern that could possibly solve this problem, so we look into the gray literature. This design called asynchronous request reply pattern or HTTP polling. In short, the server will handle we have a status indicator for a long running process. The client will periodically polling for the status. When the time is up or the client still not send the polling request, the server knows that the client goes offline and it can keep the process. The final practice is post-push patch return. When the client sends a post-push patch request to the server to create or modify some data in the server, usually the server just sends back a simple 200 OK status code. The client would never know if the object was created correctly. To solve the problem, we use the repository and unit of work pattern. The repository pattern separates the database manipulation logic with the business logic. The unit of work pattern makes sure database transaction is successfully executed before return the result to the user. Next, we will talk about the evaluation of these solutions. Now we understand the problem and their corresponding solution. We will show you how we evaluate our work. To begin, we use the questionnaire survey by ICSOC empirical standard to design a survey. Then, based on the survey result, we invite some developers for further interview to better understand the reason behind their choice. In general, 55 participants fill out the survey and we interview 5 of them. Here is the summary of the result. More than half of the participants are in 18 to 29 years old. In addition, most of them have bachelor degree. For their job, most of them are the full stack or back-end developer, so they are able to evaluate our design. 6.5% are software architect. The other professions are the project manager, data engineer, network engineer, and project associate. The majority of the participants have more than 3 years experience in their job or their domain. Some even have 10 years or more. For the country of the participants, half came from Vietnam, and the other half came from Canada. We also have the participants came from New Zealand, Germany, and USA. In general, most of the participants agree that our design is indeed a good design, except for entity linking and the server timeout. We will explain this result in the next few slides. We choose the number 70 as our point of acceptance, as suggested by Landis and Koch, on the scale for the strength of agreement. Now to explain the close agreement on the entity linking, we interviewed the participant about this good practice. Originally, developer could use the visitor pattern to implement the entity linking. However, we found out that there are an alternative approach for the same benefit of the entity linking. At the first login, the server sends the list of permissions or the list of the allow URI to the client, and whenever the client wants to make a new request, it could simply check this list. This avoids the complexity of the implementing visitor pattern in the server. For the server timeout, the participant confirmed that the original solution were used in his company, but in cooperation with other techniques due to the performance issue, such as the WebSocket, the publisher subscriber pattern, HTTP queue, and the gRPC. We will explain this technique in the next slide. The first technique is using the WebSocket protocol to maintain the two-way tunnel connection between the client and the server. The server can push the result to the client when it finishes processing. However, while improving the performance, this technique does not actually solve the problem, as the server does not know if the client went offline. A deeper look at the WebSocket protocol shows that if the developer needs the server know the client is offline or not, they can implement a simply function called ping pong using the same mechanism as the HTTP polling, but similar. Another approach is using the publisher subscriber pattern. This approach is suitable for some specific case, and again not solve the problem proposed by the server timeout practices. For the HTTP queue, which is the next major version of the HTTP network protocol, this protocol allows the use of a single connection from the client to the server. However, while browsers support this in the end of the 2015, the adoption of the HTTP queue as small since it requires encryption and had a design flaw that introduced the TCP head offline blocking problem. The gRPC stands for the Google Remote Procedure Call, in an open source remote procedure call framework that uses the HTTP queue underlying. Its complex usability makes it impossible to implement gRPC in any current browser without a proxy. In the next session, we identify some threats to our work and the way it could minimize them. In general, we only examine two most popular web frameworks, which is the Java Spring and the ASP.NET. However, there are many other web frameworks on the trending, like the Node.js use JavaScript, the Gin use Go, Grail use Groovy, and Apache Struts use Java. The web framework may have different solutions to the REST API practice. We could minimize this risk by extending the survey and ask the developer of the framework for their thought in our future work. Another threat is the bias of the developer based on their experience. The more experienced developer could spot the potential problem of the practice, but not want to test new things. The less experienced developers are willing to test the new technology, but they may not even know the problem exists. And finally, for the conclusion, we summarize our contribution to a state-of-the-art topic of the REST API practice, which are: we review the REST API practice in both academic and trade literature. We provide a concrete solution to the 6 technical practice. We validate the solution with our professional developer. That is the end of the presentation. Thank you for listening.